So do you have a CNC and you want to make some pretty crazy stuff with it? Then Fusion 360 might be a really good option for you guys, and we're going to dive into my full process on how I made this Haunted Mansion sign on a CNC. All right, what is up guys? Welcome back to the Make or Break shop. I'm Brandon, and here at the shop, we like to make things, but we know that breaking them is part of the process. And actually the breaking piece is why I love software like this. So with Fusion, you can actually run all of your different toolpaths that you're gonna use for your CNC build, and you're gonna know if you're gonna break things before you actually break them in real life. And so I find Fusion is super powerful, not only for that, but you can also do some pretty insane things. So if you're ever doing anything that isn't just like your normal sign that is just really kind of just one layer, you're just carving out pretty much like a vector file on top of it, it's got some type of 3D element to it, Fusion is going to be great for you. You can make amazing things with it. You just bring your models in and then you make your toolpath. And that's actually the full process that we're going to be getting into in this video. So I've actually made this plaque before. There's a previous video right up there that you can check out the build, but let's actually get deep into the process of doing this in Fusion. So for this process of doing CNC and CAM stuff in Fusion, there's actually 4 different steps. So the first step is going to be a model that is either a model you've created directly inside of Fusion, or that is a model that you've downloaded and you're importing them in. In the case of the Haunted Mansion, we're going to download a STL. And so then from there, you're going to move on to your second step, and that is actually creating all of the different toolpaths inside of Fusion. Then the third step is actually exporting all of your toolpaths and bringing them into your CNC control software. In my case, I'm going to be using Easel, but if you can import G-code directly into your CNC controller, then you're going to be good to go. And G-code is literally the commands that the computer sends the CNC, and then it moves it all around. So if you can import that, you're going to be good to go. And then the very last step, the microphone is in the way, is actually carving out your piece on the CNC. Again, I've already done that. That is in a previous video, which you can check out. All right, so let's jump into step number 1. All right, so our very first step is to actually grab the 3D model. In my case, I am bringing this from my mini factory. I downloaded the OBJ file from here. Now I'm switching over to Fusion, and then we can insert that mesh. Now, in my case, I have my unit set up to inches, which works right with this model, but that might not be the case for your situation. In that case, you would need to change your units first, then import. And you do that because you're going to have some scaling issues. Now, you can scale things inside of Fusion. There's a great tool that does that, but your model needs to be parametric. And we are actually not going to be creating a body, so like a parametric body from this mesh, because it makes the file super big and everything gets really wonky. And you can actually directly manufacture from a STL, OBJ, a mesh file. But if you do need to scale it, you can use a piece of software like a Mesh Mixer, which does a really good job of bringing that in. All right, so now, like I said, we've got it set to inches over here on the units. I'm gonna come up here to insert. I'm gonna go into insert mesh. And then we're gonna grab this 3D file, you can hit open, and we're going to bring it in. And then I'm gonna hit okay. All right, so now we've got it imported. So I'm just hitting I for measure, just to double check. It's coming at about 10.5 inches, which is what we are shooting for. All right, so now we've got our model in here, and we can go directly into the manufacturing workspace. So that's step 1, really easy. Just bring your model in, whatever you want to do. You really don't need to orient it any specific way. All that's going to be taken care of in the next step. So let's actually move to step 2. That's where we create stock, and we make all of our toolpaths so we can then send them to a CNC. So we're going to jump out of the design workspace, come up here to the top left, and then we're going to go into the manufacturing workspace. And this is where we're going to spend the majority of our time. And the very first thing that we do is we need to create a setup. You can have multiple setups for the part that you want to manufacture, and then you can have multiple toolpaths within each setup. Now the setup, that is where you're going to define your stock, kind of where you have your 0 on your machine, as well as some other basic parameters, and then you'll drill into the actual toolpaths on how you want to create this thing from there. So, and it kind of works from the left to the right for the most part, kind of the process that we're going to go through. So come over here to setup. We're going to open a new setup. You can see setup 1 now pops up. So we're not going to select a machine. You can do that if you have one that makes sense for you, but we're not going to worry about it. And then we do want it set up for milling. You can see cutting, turning, and additive. So that's like 3D printing stuff. Milling is what we want. But we do want to set up a couple things. First off is going to be our work coordinate system. So we're going to use our model orientation because this is actually put on the ground if the ground is kind of your XY plane. And then our stock box point. And so we'll actually get into this in a minute, kind of where the origin is going to be. I'm going to go ahead and select what the model is. Hit OK. I'm gonna go ahead and save this. I just saved it as the Haunted Mansion example. And then going back into the setup, let's go ahead and set up our stock. So you can see you can do your stock relative size to the box, a fixed size to the box, or just a straight up fixed size. And so in my case, I'm gonna do a fixed size. So we're gonna go a fixed size box. I know I'm going to be using MDF to do this. So we're going to do a width of, let's see, 12 inches. I'll do a 12 by 12. And then for the height, we're just going to do 1 inch just to make this really simple. Not only can you define the dimensions of the stock, you can actually define how the model fits within that stock. So in this case, I actually want my model to be at the very bottom of the stock. So you can do that here under the height Z instead of center. I'm going to do offset from the bottom, and then you can define an offset. And so it's not going to move what it just did. So it's giving us an offset of 0.1, but actually just want to make that 0. And this should move to the very bottom, or actually really the stock moved up. So there you can see that if we move it, the stock and the model are at the bottom. Now I'm going to jump back over into the setup. Now we can go back to our work coordinate system. And I want to do it as a stock box point. You can obviously select it by a point on the model, but more than likely you're going to want to do it as a point from the stock. And then in my case, I usually do the bottom left if you're looking at it. So we're going to go, if you're looking at the front, so you can see that my view cube, I've got it turned to the front. And I'm going to select right here as my stock point. We don't have a fixture. And then the post process, that is just like naming stuff. You don't need to worry about that. All right, so that's everything we need. Hit OK. And so also you're going to see that that stock actually goes away unless I have the setup selected. So if for whatever reason you don't see it, that's just what's going on. All right, so let's talk about how we are actually going to mill this out. I think I'm going to do 3 different operations. The first one is, again, if we go to this piece of stock, we have a good bit of material at the top that we're not going to need. So we're going to do a facing operation. This is also great if whatever reason your stock isn't perfectly flat. In my case, this is MDF. And the facing operation is just going to take away a lot of material quick, so it speeds up our later tool pass when we're going to need to use a smaller bit. And then the next one we're going to do is a 3D adaptive clearing tool path. Usually that's the one that I use when I'm doing stuff that's 3D like this. It's going to be a flat end mill. So it's going to take out the majority of the material, but it'll still obviously leave some because it can't get into all the nooks and the crannies of this guy. And then to finish it, sometimes I'll do 1 or 2 different passes, but I'm just going to do one just for example's sake, and that's going to be a parallel tool path. You can do parallel. I've also done scallop or contour. Does a pretty good job. But parallel for the most part is going to work. What it's going to do is we're going to take a ball nose bit, and it's just going to go back and forth, all the way across this model until we get something fairly smooth. But actually, we're going to do one more tool path, and that is going to be a contour tool path that will go around the edge of the entire model and leave some tabs, but that's going to be how we can take this thing out of our piece of stock. So let's actually jump into our first one. That is, again, going to be our facing one, which is this one right here. I'm going to select it. And then we're going to have our options pop up here on the right. I'm going to pull them over so you can see them hopefully a little bit better. I am not going to get into doing your surface speeds, especially your cutting feed rate. That's really going to depend on your machine, your bit. There's a lot of great resources where you can find kind of how to determine that. But I'm just going to kind of leave this as what it just gives me. But no, you're going to need to dial your cutting feed rate in depending on your situation, as well as your ramp and your plunge feed rate. But we are going to need to select our tool. So I'm going to come up here to select. So I'm actually going to let's see, I want to do a face mill. So I'm going to by tool category, milling, and then I'm selecting face mill. So we're going to come over here to tutorial inch. And you can see we have a big 2-inch face mill. So we're going to select that. Now, you actually see that the face mill shows up. And so it's kind of the faint outline of the tool itself. And that's really nice because you get kind of a perspective of how big this thing is going to be. So there's a few things that we're going to need to dial in. And so we've got our tool. Again, change those as needed. Come over here to geometry. And so right now it's set to stock contours. And I believe it's set to the setup. So you don't have to do anything here. It already knows the contour of your stock. And so it's going to take that out. Then our heights. This is something you might need to adjust every single time, depending on what you're doing. So I'm looking at the right side view, so you can kind of see up and down. Actually, I'm going to move it just a little bit so we can get the labels. We'll see. It might be a little bit easier to see what's going on. So you have, let's see, 1, 2, 3, 4. There's 5 different ones that you can change. And all these really are the different heights on your CNC. And if you kind of mouse over one and you leave it there for a second, there's going to be a drop down, a cool tooltip that will kind of walk you through what it actually means. Now, the only one we actually need to worry about is our bottom. And so as of right now, it is going to the top of our model, which is what we want. But I'm actually going to leave a little bit of a clearance just to give us a little bit extra stock to work with. So I'm going to go 0.01, and you can see that moves it up just a little bit. And everything else is going to be good. You can really dial these in. What those are going to do is help you speed up if you make those clearances or retract height smaller, but in our case, I'm just going to leave them stock to keep it pretty easy. Then coming over to passes, first is the step over. So this is like how far over the bit moves each pass. So it's going to need to be less than the diameter of the bit. And you can see with this tooltip, it gives you just a good rule of thumb, where for a flat tool, it's the diameter times 95%, or in this case, that 2 inches times 95% gives us around 1.9. which will work fine, and then multiple depths. So again, this is going to be depending on your machine. You might need to do multiple depths depending on how much you're cutting. I'm actually going to do that. I'm just going to only have it come down, even though it probably would be fine. A rule of thumb of this as well is to take your diameter divided by 2, and that's really your max depth. So in this case, it would be like 1 inch, but that's pretty crazy. So let's just do, let's go down like 1/4 of an inch and kind of see how that goes. And everything else, linking, really what these are doing is helping you optimize what the CNC is going to do. All right, hit OK. So you saw it calculating, and now it turned green. What that green is actually showing you your stock. And this isn't like the setup stock, like the yellow, but it's the actual stock that can be cut away. So I have this option actually turned on. It's called the automatic in-process stock generation. So what it will do is you can actually see what this is going to look like. I'm going to turn this off in a minute because the calculations will take a while, but so we can actually see what's happening, you can right click right here and you can go to simulate. Also up here, same thing, hit simulate. And you can see this has turned solid. And just in case yours looks different, I have my tool turned on. I have my tool path turned on. It's only set to tail. And then my stock is turned on, and I have it set to be a plastic vinyl. What this does, if I hit play, is you can actually see it cutting away. Now this is really cool. And I'm just speeding this up. A couple things also to note, there is this green bar at the very bottom. This will actually change colors. So if it's red, that means an error has happened. More than likely, the CNC has hit something. And so you can actually set it to stop on collision, which is right here. That's actually a really good thing to have checked just to make sure you're not going to break anything, because then you can go back and fix it. And then also, as we get more toolpaths, you'll see those toolpaths will be color-coded as well. I'm going to go ahead and go to the end of this, and you can see that's what our stock looks like. And then if we select our model, actually you're not gonna be able to see our model, but our model is in there and everything looks good. So I'm gonna hit close, and it's actually showing us the stock at the end of the operation. So you can see if I go into simulate again, that goes up, but I'm gonna close out of it. So that's at the end of that operation. All right, next up, so we've got our facing operation. Now we are going to do our 3D adaptive. Again, this is going to take out the majority of the material. I'm gonna be using a 1/4 inch bit to do this, and then I'll come back and really clean that up with a parallel toolpath. So we'll come up here to 3D adaptive clearing. And it automatically will select whatever bit you had before, but obviously we're not gonna do that because that is massive. Instead, we are, actually tell you what, we are gonna stick with our tutorial tools. And so I'm gonna do milling. You could just search for them right here, but I'm gonna use this guy because I'm not sure what they have. I'm gonna use an end mill, and then I'm going to use a 1/4 inch end mill. I'm gonna hit select. Again, I'm gonna leave these all default, but you can change them as needed. We're gonna come over here to geometry. So a few things that we wanna change. Right now, if we actually left our geometry as none, then it's going to machine the entire thing. So it's actually gonna remove everything else. So what this is going to do is take out any material that isn't the model. So it would literally cut to the very bottom of your stock. It would actually cut all the stock away. We don't wanna do that because we are gonna be using a contour toolpath at the very end to remove it so we can speed this up. So instead, what I want to do is actually want to select silhouette. You can see that the silhouette is just what it sounds like. It's the silhouette of your model. So I'm going to select that. And so now it's only going to cut, let me go to the top. It's only going to cut what the silhouette is inside of that. I am going to set my tool containment to be outside, and then I'm actually going to give me a little bit of an offset. I'm actually going to go out a good bit. I'm actually going to go out 1/4 inch, and that's actually to give me some space for the next operation so the bit can kind of get in there before it really has to drill down. So then we're going to leave rest machining on, and all this does is rest stands for removing the remaining stock. So if for whatever reason the toolpath before didn't remove everything that we wanted it to, if we're coming in with a smaller bit, it will. So I'm just going to leave that on. Because it's a facing operation, we shouldn't run into that, but we'll just go ahead and leave that on. And then we are going to select our model, so what we actually want to cut. So we got our model services, and then coming over to the heights, we are going to do this as well. This isn't going to be an exact copy of this model. We aren't going to be doing like a true 3D cut. We're really doing 2.5. So I think it is, you can see there, it comes in just a little bit. We're not gonna be able to cut that, which I'm okay with. And actually, especially around like the horns on this guy, it definitely cuts back in. So it really is just gonna go straight down, but that's gonna be okay for kind of my situation. The only thing I'm gonna do on this, let's see, is we can adjust our top height to be the top of our model because we've done that clearing operation before. Actually, we'll go up just a little bit, 0.02, because I think before we did 0.01. And then the bottom, we'll leave it 0. That's fine, because we'll still clear that out later. And then our passes, you might want to change your optimal load. This will be dependent on your machine and what bit you're using. We're not going to adjust that. And I am going to leave some stock to leave, so that 0.02. All these settings, it just brings in automatically. So really, I don't change a ton. One thing you do want to make sure is this maximum roughing step down. That is where I usually take the diameter of my bit divided by 2, and usually a little bit less than that is what I go with. So in this case, we're going to go 0.25. I'll just do it like this, 0.25 divided by 2, and then it takes, it calculates the fine step down from that. The linking, again, I'm not going to mess with. All right, hit OK. It's going to take it a minute to calculate everything. All right, so the toolpath is done and it looks like a hot mess. That's why I usually leave this turned off. Now, so we can actually see this work, I'm going to come over here to simulate. And again, I'm double checking to make sure there's no red so it doesn't break anything. And then actually what I like to do is I will simulate all the toolpaths. So I'll come up here to the actual setup and not the individual toolpath, and then go to simulate. I'll use this guy. This will run to the end of that toolpath, and then I'll start this one. Sometimes it doesn't do the previous toolpath, so I do that just in case. And then I'm gonna go ahead and speed this up so you can kind of see what's going on. It's also color-coded, the actual toolpath. So the green one, that was our facing, and obviously blue is what it's doing right now. Slowly leaving this guy. And then I am actually going to pause it and take it all the way to the end. And then this does turn red, but really the red at the bottom means it is just calculating. So we're going to wait to, I believe that's at the very end. We'll get there. Also, you can see so this shaded, there's two different grays. The shaded one is the facing operation, and if I hover over it, it tells me what operation it is, and then the adaptive, and then this is just the amount of time. So you can see that the majority of the time is going to be spent doing our adaptive clearing. And if we do want to see the time, come up here to stats, and you can see that the machining time as of right now is it's 2.5 hours to cut both of those. So quite a bit of time to get this thing cut out. All right, so now that we've got that one done, our next step is to move on to the parallel toolpath to really clean this model up and get it more into our finished state. The next step is to move on to our parallel toolpath so we can really dial in what we've already done and get even closer to the model. So this is going to be pretty much my finishing toolpath. You could do multiple ones of these if you wanted, but in this case, I'm just going to do one. All right, so I'm coming up here to 3D. Going down to parallel. Then I'm going to go with this ball end mill, the 0.075. Again, I'm going to leave all of these the same. Then coming over to our geometry. Again, we're going to do silhouette. It's going to be tool center on boundary. And we're not going to do an offset now. So this one should be fine. I'm going to make sure I have my model turned on. And we are going to do this guy. Then our heights. Again, we'll have all that is pretty much good to go. Except we're going to do this from the model top. This really doesn't matter, but we're going to do it anyway. And then the passes. All right, so the step over, this is where you're really going to define how high the quality finish is. So for us, I'm gonna actually just do a 0.05, and you can definitely get it a lot further down if you want. But I'm going to do 0.05 and kind of see what that looks like. Also, you can have it go in different directions. So you can go perpendicular, as well as you can set an angle if you wanted to. And then you can also have it come back the other direction as well. And if you even wanted to dial in even more, you could do perpendicular passes. So it's going to basically do a grid going one way, then the other, but that's going to pretty much double your time. So that will be a good bit longer. And I'm going to hit OK. And it's going to take it a while to calculate. All right, so that is done. We're going to go ahead and run all of these to kind of see what our finished part will look like. So I'm going to go ahead and skip to the parallel toolpath. All right, and now I'm going to run it. And you can see it is going slowly back and forth. And so it's still going to be pretty scalloped at that, was it 0.04? So I am definitely going to dial that in some more, but just wanted to give you kind of a look on how this actually works. All right, so we can see that it actually is giving us an error. I believe it is hitting. So that is because the bit, it needs to go deeper. So one thing that is actually going on is it is trying to go all the way to the bottom. Remember, we set our bottom height to the bottom of the model. Really what I could do is have that higher than the bottom, because this is actually going to cut it out on the previous adaptive step. So I'm going to go into here, and I'm actually going to edit this parallel toolpath. And I'm going to set my height to... we're going to do an offset from the bottom. So let's come up maybe 1/4 of an inch. Really, because again, that angle is not going to be able to cut anyway. So let's go actually 0.2. So it gets over just a little bit of the side, and then we should be good. And then also I'm going to increase my step over. I'm going to go 0.01. Actually, I'm going to go 0.02. So this is going to double it and see what this looks like. And there you can see, so now it's not going all the way down. So I'm going to do the same thing for the adaptive. I'm going to right click, I'm going to hit edit, then coming over here to the heights. And then for the model bottom, we're going to go 0.2. So now it shouldn't be going the entire way down, and hit OK. All right, so we just updated that adaptive, and now you can see it's only going down to right here. So it's not going all the way down, so it's not going to cut the part completely out. Same thing with the parallel toolpath, it's not going all the way down. So we're gonna go ahead and simulate all this and make sure everything is looking good. I'm actually gonna turn the collision off because I think the parallel is gonna hit just because the bit isn't super long. So in real life, I would be using a longer bit, so I shouldn't be hitting anything, but I'm gonna turn that off just so we can kind of get to the very end and see how this is going. All right, so that is our part that has been milled out for the most part. And our final step is to do a contour to cut this piece out. So we've got one toolpath left, and that is actually to cut out the contour all the way around this plaque so we can get it out of the piece of stock. Now, normally, your shape is probably going to be pretty simple. So you might have like a circle or an oval plaque or even something square, maybe like a flag that you're carving out. And then you can actually select the geometry directly. Now, if you remember, because this was a mesh, we actually didn't convert this into a body. So in terms of Fusion 360, that means it doesn't actually know where the edges are in the program. So if I come into here and actually do a contour toolpath, so I'm going to come over here to 2D, over to 2D contour. Again, I'm going to select my tool as a 1/4 inch flat end mill. And then coming over to geometry. So normally you would select a contour. So if this actually was something that we made, I would actually be able to go in and select those edges. And especially if this was just like a circle or a square, I could either select it from the sketch that we initially made it from, or directly from the model. But because it's a mesh, we can't do that. And because this is a mesh that's I mean, it's not super complicated, but it definitely has lots of different elements going all the way around it. This is the way that I have found works usually the easiest for me. This is actually to take this, take a picture of this, bring this into another program to be able to get the outline. Again, you don't have to do this. You could just draw an oval around this and then kind of clean it up afterwards, but I kind of want to show you the full process on what I did. So I took a picture of the Haunted Mansion and then I brought it into Photoshop. So I get something kind of like this. I think this was actually from Cura, which is the slicer that I use for 3D printing. That's where I actually took the screenshot, but you could do it from whatever. I actually did it from Cura because it has a darker background, because at least in Photoshop, and I know a lot of programs have something similar to this, even if you don't have the Adobe stuff, they have a select subject option. So you can see it does a pretty good job selecting the subject, and then I'm going to use that because I'm actually going to mask everything else out. Now with that masked, then I'm going to do a color overlay, because what I'm trying to do is just get this as a solid color. We're going to set this to normal and not multiply, and I'm going to make it black. And then I'm going to turn the opacity all the way up. All right, so now we have a solid black, basically silhouette. There might be a way to do this in Fusion, because again, we were using that silhouette option when we were doing the 3D adaptive, but I can't find it for the contour. So instead, I'm just doing it in Photoshop, and so I'm going to save this just as a high resolution JPEG. Now I actually want to get a vector file out of this, so you can import an SVG directly into Fusion, and so I'm going to do that inside of Illustrator. Again, you could use free vector editing software, stuff where you don't have to pay a monthly fee, but in my case I've got Adobe, so that's what I'm going to go with. So I've got this imported into Illustrator, then I'm going to come up here, I'm going to do an image trace, and then I'm going to do a black and white logo. And everything looks good. I'm going to hit expand, and then I'm going to ungroup everything with the keyboard shortcut. So I should be able to delete that white. And there we go. So I think the artboard is super tiny. Yeah. So let me make the artboard a little bit bigger so it actually is on there. And so now we actually have a vector of this guy. So I'm going to come here and go File, Save As, and this is going to be saved as an SVG. I'm just going to call this Outline. So now going back into the Fusion, I'm going to go ahead and cancel out of the 2D contour. And then I am going to go back to the design, because we're going to add a new sketch. So to do that, I'm just going to go Insert, and then insert an SVG. And the units might get a little bit wonky. All right, so there is my SVG. I'm going to import it. I'm going to open it up, and there you can see that it gives me that outline all the way around it. Now the units are off. So what I'm going to do is I'm actually going to scale this thing. Let's go by half, and then I'm going to have to kind of dial this in. Again, depending on how you're doing the units, you probably won't have to do something kind of like this, but I'm not trying to get it super exact. I really am just trying to get something fairly close to where I'm going to be able to cut this out. All right, so now we've got a new sketch in there that should have our SVG on it. So if I turn the body off, you can see that underneath. Now this isn't exact. I actually probably should have taken the screenshot from Fusion. So I think it had some like warping just because of the perspective this was in, but this is gonna work fine for what I'm trying to do. So now I'm gonna jump back over into the manufacturing workspace. And now you can see that we've got that sketch there, as well as if I turn my body back on. So now if we go in and we actually make a contour toolpath, come up to 2D contour, again selecting the 1/4 inch flat end mill. Again, all this stuff you're gonna need to adjust as needed. But then for the geometry, now we can actually select some contour. So you can see that it is back there. Again, it isn't exactly, it's actually gonna cut in a little bit more than what the thing is, but for what I'm doing, it's gonna do all right. And now I'm gonna go in and I'm gonna set up my tabs. So you can actually do it by position, or you can do it by distance. I usually do it by position so I can actually kind of dial them in. You can see that little dot, and then I'm gonna go ahead and select where those tabs are gonna go. I'm just gonna do 4. Let's see, I might actually do a couple by the horn so they don't break. And you can see when I'm putting them in, it's actually doing them on the inside. You can kind of see that tab right there. Let me turn the model off so you can see it. And so that's because it's actually going the wrong direction. So this arrow, I'm gonna click it. So I'm gonna click that arrow. That's gonna switch to the direction, and now you can see that shifted to the outside. And so then we know that's gonna be going in the right direction around the contour. And then, let's see, I think everything else looks good. We are gonna want to do multiple depths. So again, the maximum roughing step down, that's gonna be our diameter divided by 2. And then also if I wanted to make this thicker, so if I didn't want it to go just around one time, so you can do multiple roughing passes if you want it to be wider than just the width of the bit. But I'm just gonna leave it just as the width of the bit to make it simple, and then hit OK. All right, and then if we come in and take a look at this, everything is looking good. One thing I actually forgot was the height. All right, so the only thing I'm gonna change on the height is actually I'm gonna make it go down just a little bit. So I did 0.005 from the model bottom negative. So it's going down just a little bit to make sure I cut through the entire thing. Then everything else looks good. We're gonna hit OK, and we're gonna generate that toolpath. And then I'm doing it from the stock top. Just double check if it goes over into what we haven't cut, that it's still taking its time and getting down there. So we can see everything looks good. If I run just this guy, even though it's already cut stuff before, but you can see it's going to be a pretty simple toolpath. It's going to go all the way through. And then actually I am going to get an error right here, and that is because this stock bit is actually not long enough. But the bit I'm going to be using in real life actually is longer than this guy, so we're going to be fine with that. But be sure this is what all of these errors are, is that this thing is colliding with the stock because the bit isn't long enough. So you just want to make sure you're using a bit that can definitely make the entire way through. And tell you what, we'll go ahead and actually change this up. And actually, we'll go ahead and change what bit I'm using. I have this Amana tool library in here. And then I'm going to be using a 1/4 inch bit that should be fairly long. And let's see if this one can go the whole way through. And then come up to simulate. And yes, it looks like it's going to go the whole way through, and we are going to be good. All right, and then you can see the tabs are in there. Everything looks fine. Also, it's nice, it's going to give you this error. So I just ran that toolpath. I didn't run the things that happened before. So you can see in process stock is missing, stock might be inaccurate. And that is because I just ran this toolpath. And that's because the adaptive and the parallel take a long time to calculate. So I just kind of want to skip over to make sure this one was fine. But now I am going to run everything. It's going to take it a few minutes to get the full model done. But let's do that real quick. And then I'm going to take this to the very end, and we're going to see what this actually looks like. All right, so the simulation is complete, and you can see all of our different layers are done and everything's color coded. So the green again is our facing. Then the blue, which you can't really see now, was our adaptive clearing. And then this like peachy color is in our parallel. And then it's coming back with that purple, which you can kind of see with the tabs is coming in. So the only error we're getting is on the parallel toolpath. And that's because that the bit is actually not quite long enough and it's colliding as it's coming through. So in real life, the bit I'm actually going to be using is longer, and even the material I'm going to be cutting out is going to be thinner, so it's only going to be 1/4 of an inch. But for this example, I just wanted to use an inch to make it pretty simple for you guys. So once you feel good about all this, there's a couple things you can do. First is you can actually right-click the stock, and then you can go to Stock, Save Stock. And then what's nice is it's actually going to save this as a model. So if I go back over to the design, and we're going to do that real quick. I'm just going to import it. And it saves it as a mesh. It saves it as an STL. And this file is pretty big. All right, so I had to bring it in as millimeters. Actually, I dropped it too high. But you can see what this looks like. And what's nice, if I turn this guy off, if we zoom into this, obviously you can see the tabs, but what's great is you can actually see those toolpaths. So you can get a really good idea of what your final piece is going to look like. And then you could bring that into the rendering environment, and you can do a bunch of other stuff to it like you normally would with a model. But that is a pretty cool feature where you can actually see what your part potentially is gonna look like once you're done. But I am actually going to back out of that and jump back into the manufacturing environment. So now that we actually have all of our toolpaths done, we're gonna move on to step 3. So step 3 is actually exporting these toolpaths and bringing them into whatever software is actually going to run your CNC, so CNC controller. So to do that, what I typically do is if you right click these, you can go down to post process. So it's going to open up this post processor, and all this is going to do is export out your G code. So I typically don't really change this up. You will need to make sure and bring in whatever your post processor is. So in my case, this is Easel, and you can install those kind of like you can install the tool libraries, and you can bring those in. Most of the CNC manufacturers have a post processor that you can use, and really it just formats it in the way that your CNC is going to want to read it. So I'm going to go ahead and hit OK. We're going to do this on the desktop. I'm going to save all these real quick, and you can see it pops up, and literally this is just the G code. So there are some of your initial movements, and then there are all of the movements back and forth. So we're going to do the same thing for the rest of these real quick. And then another cool thing you can actually do is you can make a setup sheet. So I'm going to go ahead and hit open to that. And it is going to save a setup sheet and an example for you that basically has your model, the positioning of it, the number of operations, the number of tools. We've got 3, the maximum feed rates. Again, you need to change all that, the distances and the time. So there you can see it's nearly 3.5 hours. And then you have what each of your tools are and how they're going to be installed, all that kind of stuff. So really that is if you're doing some really heavy duty CNC stuff, this is really helpful. All right, now we are going to send this to the CNC. And to do that, you're going to have to go through your CNC software. So for my case, I've got an Xcarve, and so I'm going to show you how to do this through Easel. But if your software allows you to import G-code directly, you're going to be good to go. So even like Universal G-code Sender, which a lot of people use for DIY stuff, we can use that as well, really easy. So I've just made a new project. I'm going to call this Haunted Mansion 2 because I've done this once. And then with the way that Easel does it, you kind of set up different pages for different toolpaths. So I'm going to do 4 of these. Then I'm coming up here to File, Import G-code, then import that G-code. It's going to validate it, and then you can still see it and how it's going to look. It's not going to give you any of the time stuff it normally does because it's just G-code directly. It's also not really going to give you the bit stuff, so you just need to make sure you know that. But so I'm going to do this for all of these. So there is our adaptive clearing. There's our parallel toolpath, which that one's actually pretty cool because you can pretty much see the model because it is so fine. And then our 2D contour to cut the entire everything out. And again, because I have placed my origin down here, that's what everything is referencing off of. Actually, a lot of times I will keep my origin right here in the middle. And so then I will zero everything out from the middle. That works pretty well. But you'll just need to make sure you're using the right size stock if you're going to do something kind of like this. I think we did 12 by 12 inches. You'll want to make sure everything's zeroed correctly when you put it on. And so from this point, then you just send it to your CNC. So I've actually done this project already in a previous video. You can check it out up there. So Fusion really can take you from the very beginning, importing your model or creating your model, to creating all the toolpaths, to exporting all your G-code, to actually bringing it into your software and then running the CNC. I find it's super helpful for doing anything that is 2.5D or 3D. You can do two-sided stuff. You can get super complicated. I've even done guitars with this. It's pretty crazy what you can do inside of Fusion. And if you actually want to get deeper into all of this, I've got a full course that walks into it. You can check it out up there. But if not, I've got a bunch of other free tutorials on this site that you can check out. So let me know if you got any questions specifically about this tutorial down below. I would love to do follow-up videos with those. And until next time, go make or break something in your shop. All right, see you guys.